So, you're sitting on your couch, scrolling through your phone, when this massive lion stretches out next to you and starts purring like an oversized house cat. Weird? Sure, but here's the thing. Genetically engineering wild animals, like lions, tigers, and other predators to become docile, friendly pets, is a real possibility. We're standing at the edge of a mind-blowing technological frontier where we could potentially rewrite the genetic code of nature's most dangerous creatures. Imagine transforming a creature that would normally see you as lunch into a gentle companion. But just because we can do something, does that mean we should?
Yeah, but your scientists were so preoccupied with whether or not they could that they didn't stop to think if they should.
This isn't just about creating exotic pets. We're talking about a potential revolution in how humans interact with the animal kingdom. To really get into this, I think we need to start by quickly going over what the domestication process for animals has been over the last 10,000 years, give or take. We need to talk about how wolves went from being wild predators to the adorable tail-wagging companions we know today. Researchers have been able to use DNA and fossil evidence to determine that domestication occurred around 15,000 to 40,000 years ago. The wide range is because this time frame is estimated by looking at gene mutations, which don't happen very often. As far as where domestication happened, there is some dispute. Some research suggests they descended from wolves in Asia. Other research indicates they were domesticated twice in Asia and Europe, or the Near East. The domestication of wolves likely began when wolves learned that groups of hunter-gatherers were a fruitful food source, following bands of humans in order to enjoy the scraps of food left around their encampments, especially when hunting was difficult. From here, it's a story of the survival of the friendliest, as friendlier wolves had a major survival advantage. They got closer to human camps, scored some extra food scraps, and were less likely to be chased away or killed. Over generations, these less aggressive wolves passed down their friendly genes. Natural selection was basically running its own dating app for wolves. The most social and least threatening wolves got to have more puppies. Early humans likely weren't just passive observers. They were wolf matchmakers. When a wolf showed traits humans liked, maybe it was super calm or really good at helping with hunting, those wolves got special treatment. They were fed more, protected more, and most importantly, they got to have more puppies. Aggressive wolves were treated less fairly, possibly even becoming food for hungry hunter-gatherers. Over time, humans became super intentional about breeding. Want a wolf that's great at herding? Breed the most cooperative ones. Need a wolf that's good at protecting the camp? Choose the most alert and protective wolves for breeding. This wasn't a quick process. We're talking thousands of years of careful, deliberate selection. Each generation of wolves became a little more domesticated, a little more dog-like. The result? The incredible diversity of dogs we see today, from tiny Chihuahuas to massive Great Danes, from fluffy Samoyeds to sleek Greyhounds. All of them descended from those original, brave wolves that decided to offer their paw to the humans nearby. And now, with genetic engineering technologies like CRISPR, we might be on the cusp of an even more dramatic transformation. Imagine having a microscopic pair of scissors that could cut and paste DNA, like it's a Word document. Sounds crazy, right? Well, that's CRISPR. It's a tool that gives scientists the ability to edit genes with crazy precision. Think of it like a genetic search and replace function for living things. CRISPR stands for Clustered Regularly Interspaced Short Palindromic Repeats. But don't worry, you don't need to remember that mouthful. What matters is what it can do. Basically, CRISPR is a technique that lets scientists find specific spots in DNA, cut out unwanted genetic sequences, insert new genetic information, modify how genes work, Traditional domestication through selective breeding used to take generations. We're talking hundreds of years. In the case of wolves, the first major changes to personality and temperament may have taken 1,000 years. With CRISPR, you could theoretically change animals in the time frame of one generation. Picture DNA as a massive instruction manual for life. Before CRISPR, editing that manual was like trying to fix a book with mittens on. Clumsy and imprecise. Now scientists can go in and make exact targeted changes. The technology uses a guide RNA, think of it like a GPS for genetic editing, that finds the exact spot in the DNA you want to change. Then a special enzyme called Cas9 acts like molecular scissors, cutting the DNA at that precise location. Scientists can then either delete a gene, modify it, or insert a completely new piece of genetic code. Scientists are already using CRISPR to develop disease-resistant crops, create more resilient animal breeds, potentially cure genetic disorders, help endangered species adapt to changing environments. Remember that idea of turning a lion into a gentle house pet? CRISPR makes that seem less like science fiction and more like a potential reality. Imagine targeting the specific genes that control aggression in a lion. With CRISPR, scientists could potentially reduce prey drive, modify temperament, adjust neurochemical pathways that trigger aggressive behavior, make them have a natural obedience to humans, and to instinctively avoid any behavior that could cause harm to a human. That brings us back to the million-dollar question. Just because we can do something, does that mean we should? CRISPR isn't magic. It's powerful technology that comes with massive responsibilities. Every genetic edit could have unintended consequences. We're not just changing an animal. We might be fundamentally altering its entire existence. We're potentially rewriting the very essence of what it means to be a species. What makes a lion a lion? Is it just the golden fur, the majestic mane, the sharp teeth? Or is there something deeper, something fundamental about its nature that we can't just edit away with a few genetic tweaks? Imagine you've engineered a lion that purrs like a house cat and cuddles on the couch. Sure, it looks like a lion, but is it really a lion anymore? A species isn't just about how an animal looks. It's about behavior, genetic makeup, role in the ecosystem, thousands of years of evolutionary history. When we start messing with an animal's fundamental nature, we're potentially creating something entirely new. Do we even have the right to do this? To fundamentally reshape an animal's entire genetic heritage? It's a question that gets right to the heart of our relationship with nature. Then again, haven't humans always done this? Every breed of dog you see only exists because mankind took an active role in the selective breeding of wolves. Is this really any different than previous forms of domestication? Could it not be said that this is better, less invasive than selective breeding over generations? The risks aren't just philosophical, they're very real, such as unintended genetic consequences. What if our genetic edits cause unexpected health problems? Could we create animals with serious genetic disorders? How would these changes impact the animal's long-term survival? What about ecosystem disruption? A genetically modified predator could completely throw off the balance of an entire ecosystem. Changing one species' behavior could have ripple effects we can't even predict. Animal welfare concerns. Would these genetically modified animals actually be happy? Captivity is already stressful for wild animals. If you genetically engineer a tiger who loves captivity, have you done something unspeakably cruel, changing an animal's nature at such a fundamental level? Genetic engineering isn't just about creating exotic pets. It's about reimagining our relationship with the natural world. We're standing at a crossroads where science gives us unprecedented power to reshape life itself. But with that power comes an enormous responsibility. I ask again, at what point does a lion stop being a lion? When we've edited away its predatory instincts? when we've removed its wild nature, when it becomes something that can curl up on a couch without wanting to hunt?